And we are in A2, Unit 5, Lesson 1, and we're going to review monomials and polynomials. So this should all be familiar. You're probably not going to learn anything new. What you need to do is be refining your technique. Anytime you review, that's because this is fixing to be just a part of the problem, not the whole problem. So you need to be fluent, not stumbling your way through it. So we're going to practice. All right, first of all, what is a monomial? Well, a monomial is a number, a variable, or the product of a number and a variable. So what's that going to look like? Well, you know what numbers look like, so that could just be 3. All right, you know what variables look like, so that could just be x. Now, product gets a little more confusing, so let's do a couple of examples. You could have 3x. Remember, a product is what you get when you multiply. So 3 times x. You could have 5x squared. But I also want you to remember what happens when you multiply a fraction times a variable. It's going to look like this. This is also a monomial because you multiplied 1/3 times x to get x over 3. And one more thing, monomials do not have plus or minus signs. They have no plus or minus sign. You see all these things? There's no plus or minus. When you get into a plus or minus, that's when you have more than one monomial, which we'll talk about in just a second. Okay, so real quick, we're going to review our exponent rules. Now, you had your product rule, which said a to the m times a to the n is equal to a to the m plus n. Remember, you add. And an example of this would be like x to the second times x to the third equals x to the fifth. All right, your power property said a to the m to the n is equal to a to the m times n. And an example of that would be if I took x to the second to the third, you're going to multiply exponents, okay? Now, you've probably seen this expanded out, and that's how you come to the conclusions. This just saves you time. If you expanded both of these out, you would see you'd wind up with 5 x's here and with 6 x's here. So, just makes it shorter. All right, your quotient rule. If you have a to the m over a to the n, that's equal to a to the m minus n. So for example, if I have x to the third over x to the second, you're going to subtract. 3 minus 2 is x to the first, which you don't have to put the 1. All right, the negative exponent property tells you that a to the negative m is equal to 1 over a to the m. Now, what a negative exponent means is that number is unhappy on whichever side of the fraction bar it's on. So if you have a to the negative m, that's 1 over a to the m. But if you had 1 over a to the negative m, then you'd still flip it. Whichever side of the fraction bar that negative exponent is on, you move it to the other side and then you make it positive. And then your 0 exponent just tells you that anything to the 0 exponent is 1, except for one case. There is a special case. 0 to the 0 exponent is actually just undefined. Okay? So for example, if I had 3x squared to the 0 exponent, that's just equal to 1. Okay? So let's just grab some problems and put these into practice. Okay, here's number 1, 5x to the second times negative 7x to the sixth. Now, I want you to gain an understanding of this. Even though there's a multiplication sign here, what is actually in between the 5 and the x and the 7 and the x? Well, it's also multiplication. So actually what you have here is 4 monomials that are just all multiplied by each other. And we're just going to regroup, all right? You don't have to write this out. You're doing this in your head, but I just want you to see there's really no significance in a multiplication problem like this of these two things being grouped together and these two things being grouped together. They're really just 4 things multiplied all together. So what I have here is 5 times negative 7, so that's negative 35. And then x squared times x to the 6th is x to the 8th. Remember, if you have two bases, two exponents, you add the exponent. Okay, let's look at number 2. Negative 2a cubed b all squared times 8ab to the 9th. Well, the first thing we need to do is square everything that's in this set of parentheses. So when you take negative 2 and you square it, you get positive 4. When you take a to the 3rd and you square it, you get a to the 6th. When you take b and you square it, you get b squared. And nothing is going to change here. But now that everything's out of the parentheses, I can combine these two terms. So 4 times 8 is 32. A to the 6th times a is a to the 7th. And b to the 2nd times b to the 9th is b to the 11th. Okay, let's look at number 3. Now we have a fraction here and then we have a binomial here. So let's see if we can simplify the fraction first. All right, 54 divided by 3 is 18. M to the 6th over m to the 2nd, you subtract your exponents and the exponent goes wherever the largest one is. So 6 minus 2 is 4. The 6 is larger, so it stays on top of the fraction bar. Then this one actually has a 1 for an exponent, so n to the 4th over n to the 1st is n to the 3rd. Right? Now, fortunately, our terms match. Now we're combining by subtraction. Since the variable portion matches, not just the letters, but the exponents also, I can just do 18 minus 10 is going to give me 8. M to the 4th, n to the 3rd. Now remember, addition and subtraction will never change your exponents. For addition and subtraction, you just use those to match here, but you never change them because exponents signify multiplication. So the only thing that's going to ever change an exponent is multiplying or dividing. Okay, for number 4, we have 2k to the 4th times 10k to the negative 7. So 2 times 10 is 20. All right, now k to the 4th times k to the negative 7. You're going to add the exponents. So 4 plus negative 7 is negative 3. Now this brings in our negative exponent rule. This is actually on top of a fraction bar. So the 20 is fine. It doesn't have a negative exponent, but the k is not happy. So it needs to go to the bottom, and then the exponent becomes positive. Okay, let's look at number 5 now. 2/3 r to the 2nd s to the 7th all squared times 1/6 r cubed s. First, let's take care of this exponent. We're going to distribute it. Now, when I distribute it to that fraction, I've got to square both the numerator and the denominator. So I'm going to get 4/9. When I square r to the 2nd, I multiply exponents, so that's r to the 4th. When I square s to the 7th, I'm going to multiply, so that becomes s to the 14th. Now, nothing about this is going to change right now. Okay? Now we're ready to multiply. So first I'm going to multiply 4/9 times 1/6, which is not a problem, but I could go ahead and reduce down. First of all, 2 will go into 6 and 4. So let's reduce those. 4 divided by 2 will leave me 2, and this is 3. All right, now I'm ready to multiply 2/9 times 1/3. All right, 2 times 2 is 2. 9 times 3 is 27, so I've got 2 over 27 here, and that takes care of the fraction part. R to the 4th times r to the 3rd is r to the 7th, and s to the 14th times s is going to be s to the 15th. So 2 over 27 times r to the 7th, s to the 15th. Okay, number 6, 14w to the 12th over 7w cubed, all to the negative 1 power. Anytime you have a whole fraction raised to a negative 1 power or a negative power, whatever, the easiest thing to do before you ever start trying to simplify anything, now you can simplify in here, and we're going to do that in just a second. So it doesn't matter if you do this step first or second, in other words. But to the negative 1 exponent just means that I'm going to flip the whole fraction, okay? All that did is make the -1 positive, and anything to a +1 power is just that thing. So the only thing that negative exponent did was cause me to flip my fraction. Now I'm ready to reduce. 7 will go into 14 and leave 2 down here. W to the third goes into W to the 12th. You subtract your exponents, so you get W to the 9th. So your final answer is 1 over 2 W to the 9th. Anytime everything cancels out, what you're actually left with is 1, because these things divided out. Okay, 1 over 2W to the 9th. Okay, number 7 is 15x to the 10th y to the 4th over 24x to the 12th y to the 3rd. So let's start reducing. What number will go into 15 and 24? 3 will. So if I divide 15 by 3, I get 5, and 24 divided by 3 is 8. So that simplifies the constant part. All right, now I'm going to be subtracting exponents. X to the 10th over x to the 12th. If you always subtract the small number from the large number and then put your answer where the biggest exponent was, you won't ever get a negative, well, you usually won't get a negative exponent, and you will get the right answer. So if I do 12 minus 10, that gives me x to the 2nd, and I'm going to put my answer where the largest exponent is. If you do ever get a negative exponent, you just know you have to flip it. You have to put it on the other side. Now, y to the 4th over y to the 3rd, I'm still going to subtract 4 minus 3, which is y to the 1st, and my largest exponent is on top, and you don't have to put the 1 exponent. Okay, let's look at number 8. So we've got exponents outside the parentheses. Let's get rid of those first, or let's distribute those first. So here I'm going to have c to the 4th over, and when I take c to the 2nd and to the 4th, that's going to give me c to the 8th. All right, now when I take the -3 and raise it to the 4th power, since this is even, it's going to make this positive 81 c to the 4th. And you know, if you wanted to reduce this down first, you can. On all of these problems, if you reduce first and then simplify, you're going to get the same answer as if you simplify and then reduce. So it just, whichever one appeals to you. Okay, so now when I multiply this, I'm going to get c to the 4th times this is going to be 81 c to the 8th, because I added these two things, over c to the 8th. The c to the 8ths cancel out. So your final answer is just the constant term, 81. Okay, number 9 says, give an example of two monomials with a quotient of -3n squared over m. So two monomials with a quotient means divide, which is just a fraction. So they want us to write a fraction that if we reduced it down, we would get that. So first of all, one number is going to have to be negative for us to have a negative. So what could I put on top and bottom here that if they reduce down, I would get a 3 on the top? Well, how about 15 over 5? That would reduce down. All right, next let's look at the m on the bottom. Well, if I want an m on the bottom, that means this, I would have to have one more on the bottom than on the top. So let's make this m to the 3rd, m to the 2nd. If they reduce down, you get the m. All right, now for the n. What I have to do on the ends is I'm going to need 2 more n's on the top than on the bottom. So I could put 5 and 7. That would reduce down, okay? Now we're going to talk about a polynomial. A polynomial is when you have a sum or difference of monomials. So what a polynomial is going to have that a monomial never will is plus and minus signs. All right, these will have at least one plus or minus, and they could have more than that. Now, the highest exponent in a polynomial is called its degree. So when you look at your polynomial, like 5x to the 5th, y to the 2nd, plus 2x to the 3rd, y to the 4th. When I look at all those exponents, the highest one is the degree. So the degree of this polynomial is 5, and that's all it means. Now, standard form is when you always write your exponents in descending order. So you look at all your terms, all your monomials in this polynomial, and you find, first of all, what if you have more than one letter, X, Y, Z, or A, B, C? You go alphabetically. So let's say you find X first, and then you're going to list all of the terms that have an X in descending order according to the exponent of X. If you have more terms left over, you go to the next letter. So that would be Y, and continue on for Y, and you do that through the whole alphabet, okay? So let's look at some examples. Okay, okay, let's start with number 10. So I only have one variable in there, so let's go for the highest exponent. The highest exponent that I have is the negative k to the 5th, and I'm going to cross them off as I get them down. All right, my next exponent is this minus k to the 3rd. Now remember, a sign always belong to the number that comes after it. So that minus belongs to that 3. So I'm going to have minus 3k to the 3rd. All right, the next thing is this plus 1/4 k to the 2nd. Then I have plus 8k minus 1. So that is standard form of that polynomial. All right, now let's come down to number 11. This one has A's and B's, so I'm going to start with my A. Find the A. Now find the largest exponent of A that you have. I've got 4a to the 3rd here, so I'm going to do that first. All right, my next exponent of A is this one right here, 18 a to the 2nd, b to the 2nd. Now remember, I'm focused on the A's, so next is this 7ab. Now I'm out of A's, so I go to B. There's only one left, but even if there weren't, you would pick the B with the highest exponent and then work your way down. All right, number 12, I have X's and Y's, so I'm going to go alphabetically, find the X first that has the highest exponent. So this one has an X to the 3rd power. So I'm going to start with 9x to the 3rd y. All right, looking for my next X. Here's a minus x to the 2nd, minus x squared. Then what? Well, here's one that has an x to the 1st exponent, so it's going to be positive 5x y squared. All right, next, I'm out of x's, so I go to my next letter, which is y. All right, all I have is that y to the 4th, cross it out, and now I have the plus 2 at the very end. Okay, now we're going to look at how to classify polynomials. And this is just descriptors, ways to describe the polynomial. There's two different descriptors. There's a degree and there's a number of terms. So each polynomial can have one of each, right? So a double descriptor. First of all, you look at the degree of it. A degree of 0 is a constant. Now, how does that work? Well, what's a constant? It's just a number, like 5. Well, why is that degree 0? Well, what you actually have here, you just don't see it. You could say this is 5 times x to the 0 power. So that's why 0 power is a constant. It's just a number because x to the 0 is 1. All right, degree of 1 means it is linear. And that would be like 5x. Even though you don't see the 1 degree, it's there. All right, second degree is a quadratic. And that one gets kind of confusing because you don't think of quad as 2, but there is a reason for it. All right, it's mainly because it's double the square. But anyway, so x to the 2nd would be quadratic. All right, what about 3? Well, that's going to be your cubic. So you could have 5x to the 3rd. That term is cubic. 4th is called quartic. So that would be 5x to the 4th. And then the last one, number 5, is quintic. 5x to the 5th would be an example. All right, now, polynomials can also be described by how many terms there are. And first of all, if you have one term, we talked about that, that is a monomial, like 3xy. That would be an example. All right, next is a binomial. Well, that means two terms. So an example of that would be 3xy plus 5. If it's got two terms, you've got one plus or minus. All right, a three-termer is called a trinomial. So that would be 3x plus 2y minus 7. Two signs, three terms. Now, anything larger than that is just called a polynomial. Poly means many, nomial means term. And to be honest, even binomials and trinomials are polys. We just have special names for those. But they are also polynomials, just like a 4 or more is. Okay, so let's try to classify some. Okay, for each of these problems, we want to classify it according to degree and number of terms. So we're going to have 2 words for each problem. All right, when you look for degree, you are looking for the highest exponent in the whole expression. And the highest exponent in this expression is the 1. So this is going to be linear. And how many terms does it have? 2. So it is a binomial. All right, number 14. I look for my highest exponent, which is 5. So this is going to be a quintic. And how many terms does it have? 3. So it is a quintic trinomial. All right, for number 15, I just have a number. So how is it classified according to degree? Well, that's a 0 degree, which was what? Constant. And how many terms does it have? Well, it's a monomial. No plus or minus sign. I spelled that wrong. M-O-N-O-M-I-A-L. Okay. Now this one, look for your degree. The highest degree is a 3, so that is cubic. And how many terms do you have? Remember, terms are separated by plus and minus signs, so you have 4 or more. We're just going to call that a polynomial. There is no special name. Okay, degree here is 2, so that's quadratic. And how many terms do you have? 3. So that's a trinomial. And then here, what do I have? 4 is my highest degree, so that is quartic. And it's a monomial. Okay, for number 19, they want me to give a cubic binomial. So cubic is to the 3rd power. So I can just put 2x to the 3rd. Now binomial means 2 terms. So, all right. Then a linear monomial. Linear means only one, the exponent of 1. So that would be a linear monomial. No higher exponent than 1. And only 1 term.